if technology is with us, the clicker should work again. Yeah. Okay. So apparently you have to press down to change the color. Okay. I'm going to blame it on him.
Yeah, I'll blame it on him. Since I was very English for me.
Okay, so we have Debora Engelmann that is going to present us work. The acronym is very hard to read. RV for Jaka, I guess. Yes. Runtime verification for multi-agent systems.
Thank you. Good morning, everyone. Thank you for being here. I am Debora Engelmann. These are my collaborators. I will present to you our paper, RV for Jaka, Runtime Verification for Multi-Agent System. I'm going to start by talking about some important concepts to understand our proposal. Then I will tell you about our case study, our approach, and finally about some conclusions and future work. So related to the concepts, we are using in our work Giacomo framework, which is a framework to develop multi-agent systems, where the MOISE provides us the organization dimension, so we can program the organization of our agents using MOISE. Cartago provides us the environment dimension, where we program the environment for our agents, and we can make the communication with the external environment. And with JSON, we program the reasoning of our agents. I think most of you are aware about runtime verification, but for those who are not, it is a formal verification technique that focuses on checking the behavior of the systems, software or hardware systems. It's more dynamic and lightweight than other formal verification techniques, such as model checking or theorem provers. And it focuses on checking how the system behaves. To do the runtime verification, we are using runtime monitoring language, which is a domain-specific language for specifying highly expressive properties, such as the non-context-free ones. We are using RML because of its support of parametric specification and because of its native use for defining interaction protocols. In fact, the language where RML is based upon was born to define communication protocols. So in RV for Jaka, we can use other kinds of formalisms. We can integrate them easily to RV for Jaka, but we are using in this work runtime monitoring language. So moving on to our approach. Here we have an overview of our approach, which is composed by a sniffer class programmed in Java, which observe all communication exchanged between agents in the multi-agent systems. An artifact programmed in the Cartago environment. So this artifact is called RV for Jaka artifact. It's responsible for analyze all the messages observed by the sniffer and translate them to a JSON object to send by a REST request to our RML monitor. Here it's important to say that we can use other kinds of monitors, but we are using RML because of it's the most suitable candidate for the properties we are interested in for check these properties. So if we need to interfere in the multi-agent behavior during the execution, we can add a monitor, an agent monitor inside the multi-agent system. In this case, when our monitor, our RML monitor in this case, perceives some violation of some property, it sends to our RV4JACA artifact that will add a belief in the belief base of the agent. And this agent will be able to send a message to the other agents that are involved in that communication that causes the violation. It may trigger some recovery mechanism inside the other agents to do something to recover with this violation. Or our monitor can perform other kinds of activities depending on the system needs, what our system needs. Okay. Now, with relation to our case study, we are working on an explainable multi-agent system to add in decision making. We are applying this explainable multi-agent system in a hospital bed allocation domain. Our users in this case are the hospital staff responsible for perform the hospital bed allocation, which means the people who works in the hospital and decide this patient will be allocated in this bed and so on. We have communication with natural language with our users. So in our case, we cannot only think about a dialogue between agents, but we need to take care about dialogue between agents and humans too. So to understand the flow of information in the system, our user interact with our system using a chatbot. So all the interactions made by the user are classified in intentions that are received by our communication expert agent assigned to that specific user. So for each user, we have a communication expert agent assigned to them. This communication expert, depending on the intent of it receives from the user, will send a message to our assistant agent, who is responsible for perform augmentation reasoning and for communicate with other agents, searching for information or asking for execution of some task or something like that. So here we have some agents that are domain specific. These agents are specific for the bed allocation domain. So we have a validator who validates the bed allocation plane, saying that there was a violation in sense of we have a lot of rules we need to follow to perform this bed allocation, like we cannot put a male patient in the same room that a female patient, for example. So this agent do this kind of violation based on a plan made by the user. We have the database agent who is responsible for communicate with the database and search for information that on that. We have the optimizer agent responsible for perform some optimizations suggestions, some suggestions of optimized allocations. And we have an ontology expert responsible for have access to the ontology, where we put some rules. These rules we need to follow to do the bed allocation, and we translate them automatically to argumentation schemes to be able to reason about that in this ontology expert. So assistant communicate with all of these agents, searching for information, asking for some task to be performed, and then answer to the communication expert that translates the answer to natural language and send back to the user. In this scenario, we add the RV4JACA and a monitor agent to check some formal properties. For example, in this property, we are interested in check that always when agent receive a question, it will answer this question before posting a new one. So following the RML syntax, in lines 1 to 5, we are defining what a question is. So the question needs to have the performative question and a sender and a receiver. In lines 6 to 10, we are defining what an answer is. So the performative is assert, and we have also a sender and a receiver. And here we define our main that says that if there is a question from the first agent to the second agent, it must be followed by an answer from the second agent to the first agent. Note that here we are ignoring all the communications exchanged between other agents in the meantime. We are caring only about the communication between two specific agents. Here we have another property that is checked by our RML monitor, a little more complex than the first one. But the main thing is in this property, we are checking change of the topic. So it helps us to be sure that our human user will not change the subject before the system completes some task. For example, in this case, when the user asks for an allocation, one result for some validation, for a result of the validation of some plan of the allocation that they made, the answer will the answer by the system will be the result of the allocation, saying that it broke some rules, or it's not any rules are broken, and it will ask if the user wants to confirm this allocation, if it wants the system to allocate the patients based on this plan. The answers that the user can can send to the system must be yes, you can allocate all the patients, even if there is some rule being broken or not, or okay, send me optimized allocation suggestion, or even do not allocate the patients. I don't want to allocate, or if the user wants, it can they can allocate only the patients who have the allocation valid, and ignore those ones that are broken rules. But sometimes the user sends another thing to the system, like it can ask for another validation of the allocation, or maybe ask if some bed is suitable for some patient, changing the topic of the discussion. And in this case, this validation that was being performed for the system will be open, will be unfinished in the system, and it can cause some unexpected behavior in the system. So because of that, we are checking this property, and with this, our RML monitor will be able to see, oh, okay, there was a change of topic in this moment. So for conclude, I will tell you about our conclusions and future work. We have presented a case study where we use RV4JACA in practice, and we have promising preliminary results. We create two distinct properties to be checked at runtime, And we created that before Jaca in a way that is possible apply it to different scenarios, to different multi-agent systems easily. So we can say that we have significant progress toward obtaining guarantees of the correct executions of the multi-agent systems. And for future work, we want to extend RV4Jaca to more than interaction protocols. For example, checking the agent's state of mind too, and create a library of verifiably correct agent interaction protocols. So here we have some references I used in this presentation. And if there are any questions, I will be happy to address them. Thank you.
Thank you very much for the talk. I think yes.
First, hi Deborah, it's nice to see you.
Hi, nice to see you.
So I have a very quick question. So you mentioned you have two properties for your case study, right?
Mm-hmm.
But it wasn't clear to me if you have one agent, one monitor agent per property, or if it's only one monitor agent that it manages all of the properties. Is that okay?
It is only one monitor agent and it manages all the properties.
Oh, okay.
Mm-hmm.
So, quick question. You mentioned at some point that you can monitor also properties which are not context free. Do you have some? I mean, how to specify that they only show some regular expressions?
My background is not so in runtime verification, so I think my collaborator Angelo will answer better this question.
I really regret that sentence in the slide. Yeah, well, we can describe also non-context-free specifications because you have these kind of terms that are cyclic, and then you have the concatenation, and then you have the parameters. So practically, you can also have a specification like AN, BN, CN, well, each one is with a different number. But it is a bit complicated in the base, really depending on this syntax, which is not very intuitive, but yeah.
So it's based on the regular expressions with some additions that make it.
Yeah, there are additional operators, but yeah.
Thank you for the talk. Maybe this is related to your future work, but if I understand correctly, the way that you're doing things at the moment is that because you're looking at the level of the protocol, you detect the problem after it's happened. So two hopefully short questions to follow from that. One is, how do you fix things so that the user isn't aware of the problem, or can you do that? And secondly, wouldn't it be better to actually trap the problem inside the agent before it actually makes it out into the rest of the system and potentially spreads to the user and so on?
Actually, thank you for your question. Actually, we perceive the problem happen after it happens, but we can recover before it causes some bigger problem in the system. Like we perceive the violation, and then we can recover. We recover we send some message from our agent, our monitor agent, to the other agents, and then inside this other agent we have some mechanism to recover. For example, in this case where the people change the topic, what we do in abstract way, saying we send a message from the monitor to the other agents and saying, okay, the human changed the topic, take care about that. Then the agents, depending on what is the way that the human changed the topic, it will ask the human again, okay, I can answer you after about it, this you are asking now, but before answer, I need to say to see if I need if you want me to conclude this validation I was doing, to conclude this task I was doing before. how can I conclude that to then continue doing what do we want to do. This is the way we are doing in this case, but depending on the domain, depending on the system you are applying the RV4JACA, you can maybe, for example, there is a violation, you can send an email to someone to make people aware that there was this violation, and then people do something to recover, or even inside the multi-agent system. In some examples, we can only close, for example, in this example of the validation, we can only, okay, I will close this thing we are doing before without an answer of the agent, only to not be here, because if it comes another plan to validate, I will have some information open about the validation before. So I can only close this information and let it away. So I'm not sure if I answered properly your question, but.
Thank you.
Okay, let's say to thank Debora again. Thank you.